What if you could hear what math sounds like? What does math actually sound like? If you could put it to music and make music out of math, what would it sound like? In fact, all music is math, if you think about it. So what if math could talk, or sing, or make music? What would it sound like? So, you know, how every function basically has a shape or a curve. Anyway, we'll get into that. Let's look at what we built. So I was talking to someone, and the topic came. The topic is math, and so I don't know how else to explain this. We just talked about this, and I was like, oh, let's kind of see what it looks like. So I made this and put it together really quickly, and let's go. So how do I do this? What's the best way to do this? Okay, so let's do this quickly. All right. Okay, so here we have functions. I'm not sure if you can see everything. You should be able to see it all. So we have functions, and then we have sine, cosine, tan, all the different formulas on the side you can see here. So just zoom in a bit. We even have hacksaw, and oh, this looks so cool. Yes. Okay, so when you click on it, there's little music, sounds, stuff like that. And then here we have oscillators, right? We have the different things. I'm not going to really explain this. I just want to show you real quick, and then I'll explain it later on. But basically, you can change the BPM, the beats per minute. You can change the beats, loops, all the different things. I don't want to get too complicated. Okay, so let's go with this one, and let's just play this. And let's start changing a few things up together. Let's change the BPM. Let's make it go faster. Okay, here we have the live waveform, and if you click on it, it will distort it a bit. And here we have the frequency spectrum. So let's just add more beats to the loop. And here you can still see, I think this is a bit too complicated to start with. Let's do a simple one like this. Sine over sine, function equals cosine x. Okay, so let's change the frequency a bit, so it's more interesting, right? 720. This is interesting. I love the spectrum of the frequency. Yeah. Isn't this amazing? Oh, we can even adjust the reverb. Oh, this is so awesome. Harmonics. Oh, note duration. I like this a lot. This is... Oh wow. Okay. X squared. I'm not sure what this is. I think the chart needs to be, I need to adjust the chart a bit. Okay, this is a bit alright. Let me just pause it for here. Okay, so here you can actually see as I move my mouse, I'm not sure, I should adjust the colors for the text, but the bottom, if you see the bottom here, around here, you can see like x, what is the value of x and the value of function and the frequency, how many hertz it is. So it's very, very cool. So if I click here, right, you can see exactly here what the x value is. So there's a I think I should add like the key, or yeah, the note that is being played. I think that's something we can add to this. So if you have ideas of what we can add, how we can improve this, let me know. But this is currently, I think even to like zoom in, zoom out to this, that'd be something we can add to this as well. But I think this is a good start. This was really cool. Like, it was very suspenseful. And I'm gonna keep playing with this. It's kind of really interesting. Wow. Oh, look at this. 10. This is amazing. Okay, let me pause it. So I think I just dove into the deep end with this. I think I'm gonna make like simpler videos, but I think this is a really good I've been working on other stuff as well, how to make math into music, but this was like, let's jump into the deep end, let's make this as crazy as we can. Let's throw the kitchen sink and everything into this and see what happens. So let me just recap a bit. Like, I know you probably have like no idea what's going on, some of you, and I don't want to get too deep into the math or the music theory and whatnot, because that's not my forte. So okay, so basically let me just summarize this a bit in a very short thing, and then we can end and we can continue with more videos like this. If you like this kind of video, let me know, put in the comments. So let me just quickly give you like a 1 minute or 30-second explanation, right? So every math function has a shape, as you can see here. There's a shape for sine, cosine, tan, and all the other stuff, right? So every math function has a shape, a curve, and the curve has highs and lows, as we can see. This, the sine wave, they're all waves, right? So there's a curve, and the curve have highs and lows. So if we take a shape, if we take a shape like this, right, and we make a melody out of this using all these other tools we have here, make beats, make loops, right? Then we can make a melody, and with every point on this wave, every point on this curve, let's just call it curve. Every point on the curve makes a pitch. So a pitch is a sound, a note. So the high point is a note, a low point is also a note, but it's a high note and a low note. Okay, and so the function basically plays itself, right? It just follows along the wave or the curve. So if the sine wave curve, it is smooth and even, right? It goes up and down, up and down, up and down, but in a very, very nice, compared to the sawtooth, right? It's like very jagged. So so this is smooth, even, almost hypnotic. But then when you look at the this one, when you look at this, right, it's very jarring. It kind of crashes down, it goes down, and then it goes all the way up, like a low note, high pitch, low pitch, and then it climbs right up, like immediately. It's like just straight line up, like a number goes up, right? It goes right up, and then it's very different, and then That's the sine. What's the other one? This one. Yeah, this one is also interesting. It's very very smooth, but it's not going up and down as evenly, right? It's just very slowly, like ripples on the water surface on a pond, right? And then suddenly you throw a pebble in, and then it just goes like this high part, and then it goes down again, and then it slowly the ripple dissipates. I think that's the easiest way I can explain it. So yeah, the wave basically describes a sound. So we're making music, we're making sounds. Well, not really music. Music is a lot more complicated. So let's make sounds. We make sounds by following the waveform, as we can see here, as well as the frequency. We can see different things. So math, like if people in school, I think if I was taught this in school, right, this is so much cooler. Like this is what music looks like. This is what math looks like. So when math and music marries, this is what you see. So if only you were taught this in school. Anyway, that's a whole different video we can talk about. But every equation, basically every equation here, like every equation here, every formula, has a voice, and we heard a bit of that right now, just now. And then you just need to know how to listen. So if we had this tool, and I might share this tool if you guys are interested later on. I'm going to develop this and we'll see what happens. But you know, like I think we need to add a volume thing so that it wouldn't always be constant. We can add a whole bunch of stuff. Let me know what you want to add, how to improve this. This is something that we built, and yeah, so yeah, basically I built this, right, so we can listen to any function, and these are the popular functions. If there's a more complicated one, let me know. Maybe you can try to add it and like try to get more coffee and figure it out. But so yeah, turning equations into songs and music and beats and rhythm and loops is a cool idea. So yeah, what is the shape of your math? What is the shape of your sound and formulas? Okay, so this is just a demonstration. Hope you enjoyed this. We'll see you in the next one. See you in the next video. Let me know if you like this kind of stuff. Bye.